Right then, Liam here again. So, been working on a project for someone. It's eventually, when I actually get round to building the hardware, will be a power supply for tattoo machines. It's going to be like remote controlled, so the tattooist doesn't have to touch it because you've got a sterile environment. So the remote control is just a little slimline thing that can be wrapped in some kind of plastic wrap and and disposed of, and the remote itself is easily wiped clean. But anyway, it's going to have various other bits and bobs on it as well. So whilst I was on eBay looking for a remote controller, I came across it's like called an RF starter kit or something for an Arduino, and it was a case. It come with like an IR detector, sender, and some other little modules in it, and an Arduino Uno board. Well, I've known of our Arduino for years, and I've never bothered with one, so I thought I'd buy it. So anyway, if you've never seen an Arduino, they come in all manners of shapes and sizes. This one is an Uno, an upside down Uno. So yeah, this is an Uno. So it's a little Atmel, one of the Atmel range of microprocessors rather than one of Microchip's ones, although I believe Microchip brought Atmel out now anyway, and so it's technically one of Microchip's processors, but it's a different topology. So that's the board itself. They are a fantastic little thing. You've got just simple USB for programming, the external power if you want, and they come with a header, and you can get like these. They call them shields. It's on a Raspberry Pi, it would be called a hat, I guess. Similar thing, and basically, so it will lock. Pins will go in. Yeah, this one actually doesn't have enough pins. Some of the pins aren't connected, but yeah, it goes in, and then you've got like screw terminals on it. So if you're projecting, or you can leave that in place in a project just fine, prototyping, whatever. But they come in different sizes. Well, this is what is this one? A Nano, I think. I think this is a Nano. So that's the actual Nano there, this little bit, and then you can see it's again similar thing. It's got a shield on it with connectors I've plugged it into. And they come even smaller. I think this is called a Micro, one of the generic. If it'll focus in on it, there you are. Yeah. So even smaller. That one doesn't have a USB port on it, so you need it's like a serial converter type thingy that you have to plug into it, and that's got the USB port in to program it. But so anyway, I've been messing about with these for a few weeks. I've downloaded the Arduino software, obviously, and the support out there for the Arduino is just absolutely incredible. There's some really good libraries written, and you could get quite a lot of programming up and running with barely having to write any more than a few lines of code to use other people's libraries, which is really good. And I will be messing around with them a lot more. I need to learn how to do things like create your own libraries and header files and stuff, sort of things. So when you've created a library, in future use, you just have it all in separate headers. It's nice to break a program out like that. So if you've got a section for your like your IR sensor, so you've got external memory, you've got various external modules around, have it all on one page. You break it up over separate pages, and your main program just basically calls each one of those functions as and when you need them, sends whatever data to them from one function across to the main and to the other function, returns it, whatever it is you're doing. Because it's a bit cumbersome having it all on one page, and at present things I've been messing around with, apart from the library files, have pretty much all just been one page programs. So anyway, so went back to my good old PICs. I like programming PICs. I've been messing around these for probably the best part of a decade now. So this is a handy little prototype board. I didn't even realise I had this until the other week. I brought like a PIC Kit 2, and it had various boards in it. Ooh, probably maybe 8-9 years ago. And I've just been using like one that has some LEDs and a button and a potentiometer on it. And then at the bottom of the box I noted this one, which is just fantastic. It's got a socket here for a PIC16F54. I've got 12 megahertz crystal oscillator on it. header, which oddly enough, instead of coming all the way down and having you access to all the pins, only does like some of the RC and RA ports, and some of them are annoyingly the same ones the PIC kit uses to program it. So if you've got something connected to it, you get issues when you're trying to program it, so you have to keep pulling them out. So if when I was trying to use this, I need to solder a header onto here because I just couldn't be bothered at tying it downstairs, but I was just having the jumper wires just sort of resting in the holes here. But so yeah, someone stuck a piece of breadboard on this so you can loop across to the breadboard, then out the breadboard to all over the place, plug things into the breadboard and that lot. So very handy little prototype board. So anyway, so the program I've been working on it picks up obviously RFID, remote control, well, not RFID, infrared. Picks up infrared or NEC protocol from a remote control. Interface with that is the entire input and output interface for it. There's no hardware buttons, everything's going to be done by remote control. But other things, it connects to an LCD display, that's the output on it. I'm toying with whether to also put a 7-seg LED display, because obviously LCDs can be a bit, you have to be at the right angle sometimes to see them. So everything can be written on the LCD display, but the LED, the 7-seg LED, if it's just the voltage readout of the power supply, a quick glance can be looked at. Let's see how I go, whether I do or not. Anyway, it's also got an RTC real-time clock module based around the DS1302. And I'm thinking I might shove some external memory on it. I'm still toying with, I need to do some experiments. I plan on videoing them when I do them. I've got in here, let's have a look. There's various modules in here, and some of them I think are some DAC chips. Yeah, there's like some 10-bit digital to analog converters. I think it might be these. So what I'm toying with, I'm unsure as to whether the analog output, just to use the pulse width modulation pins and like a 24 decibel RC network to attenuate it to DC, or whether to actually go to full-on analog to digital conversion, or digital to analog conversion, have an analog output passing that through some kind of amplifier stage. Whichever way I do, the actual display readout won't just be hard-coded that, say, the user selects 3 volts. It's not just going to say 3 volts and assume it's doing that. It will actually loop back, measure the output and display the output, because that way if there's a fault with the hardware, say for instance the short circuit protections kick in and every time they press the pedal down to get current out of the thing, the voltage is going to collapse and it'll show on the screen. And likewise, if something malfunctions on the hardware, it will show there's an issue. It's just, you know, it helps things. But anyway, so yeah, that's a bit binary. I got a bit off topic there. The purpose of this video was what I've got on the bench in front of me here. And what that is, by the way, if there's a strange little pause there, it's because this Nikon camera will only record like 9.5 minutes. I think it's to circumnavigate some kind of tax law about video cameras imports. So every like 9 minutes you have to stop it and restart the next section. Anyway, so this is an old PIC Kit 1 programmer of all things, and the reason I'm using the PIC Kit 1 is because the chip above does not meet the support of a PIC Kit 2, and I don't have a PIC Kit 3, which I'd need. So first of all, in order to program this chip, I've had to download MPLab, an earlier version. I think I just went for like the 7 point something because I knew it supported PIC Kit 1. The later versions don't, X doesn't. So I've had to download MPLab, an earlier version, compile the C code I've wrote in MPLab X, export the hex file over to MPLab 7 point whatever it is, and then serial port it across from MPLab, the earlier version, into the PIC Kit 1, in circuit serial program connection to this breadboard. And this little chip on here, this little beauty buried away at the back there, where my finger's wobbling around, is a baseline flash PIC16F54. Now, if you don't know what baseline flash are, they're like the real simple range of chips. There, if you've got a dead simple application that doesn't require massive amounts of code, or, you know, particularly sophisticated chips with various software and hardware functions on them. It's just for, like, if you want a good chunk of in-out ports, the bigger ones are anyway, and if you want some real simple code. Now, it has a massive 25 bytes, that's 25, not kilobytes, just 25 bytes of user RAM. So if I designate RAM locations for certain file registers, so for instance I have one for these 6 values that are alternating on this display, that takes up 25% of the user RAM already. And whilst the rest of the code on here needs excuse me, needs various temporary file registers and static file registers, I had to do a lot of messing around to actually get the program to fit in it. Now, if you're wondering why I even bothered with it, it just became, there was an issue with this. I've been blasting programs in and out of this, messing around, you know, altering them, getting to interface with all manner of things, and all of a sudden nothing would work anymore. It just completely stopped dead. Well, I was getting some erratic operation, and then all of a sudden just nothing. And if you're wondering what I'm doing here, I'm just putting an LED in. There is a reason for that. I will come back to it. Yeah, I was just absolutely dead. Nothing happening whatsoever. I need to pause you a moment. That's better. Right, so yeah, so it was just dead. So I went, it got to the point I ended up like completely removing all the linked files I had on my project to just going back to a basic good old-fashioned flashing LED like you see on here, and even that wouldn't work. And I'm going through the configuration settings and everything's correct, and I'm thinking, well, if the LED won't even light up, I'm not even getting to the first line of my program. I'm like, the chip says it's programming okay, so the logic that I concluded was that the oscillator wasn't running. So these, if you don't know, you can have an external oscillator, but most of the PICs have an internal one as well. This one actually has an 8 meg one. You can choose between running it at 8 megs or dividing it through various stack registers right down to 32 kilohertz. As soon as I switched over to the internal oscillator, boom, come into life. So I know I have some other PIC16F690 somewhere, but I could not find them. I found them now, oddly enough, after ordering some more, which is always the way. So rather than trying to unsolder this to see if it was this resonator or not, crystal, I thought I'd just change the PIC over and see. But what really got me as odd is these have like an internal interrupt, and they actually have a startup, a piece of code, and they start up and they check that the external oscillator is running. If not, they switch over. They should switch over to the internal one, bring up an interrupt flag, and then carry on running the program. And because the interrupts come up, you can use software to sort of try and alter the way the program runs to compensate for the fact you've lost your high precision external oscillator and you're just running on a low precision internal one. But I couldn't even seem to get that working, so I kind of feel there's actually an issue with the chip itself. Something's gone wrong with it. Maybe static discharge or something, who knows. But anyway, again, off topic. So whilst digging around at this old PIC16F54, I was just curious, what could I fit into it? So I call this the clock that can't be set. Now it is telling near perfect time. I don't know if you can read it. It says, if I try and move some wires out of the way. So yeah, it is 8:30 at night and 12 seconds, give or take a few hundred milliseconds. It's not radio fed. But the reason it's called the clock that can't be set is because there is physically not only no buttons to set the thing, there is no programming in this chip to set it. Nothing. And you wonder, well, how do you set a clock that can't be set? And the way it was done, it was set with this chip. The programming to run the clock, so that fetches the data and displays it on the screen, had to be removed from the chip, and just the programming to set it was put in. So as there's no buttons or anything and no display driver, the only way to set it is to actually manually, in the header file of the program, the main, like the first piece of code it executes, is to actually put the settings, the values you wish to set in there. It takes about 3 seconds from pressing the button on the computer, getting them into the chip, up and running. So basically, if you set it bang on 8:30, it's 8:29 and 57 seconds, you'd hit program and it'll be programmed. Now, the reason you can then remove the programming settings and put the display driver and fetch settings in is because the chip itself isn't telling the time. It's executing a piece of code which is interfacing with this thing there with the battery on it, that little module, and that is the DS1302 RTC real-time clock module. So once it's setting up and running, because it's got battery backup, you can actually completely remove power from it. You can pull it out, and you see now the display just gives us question marks on the seconds, and that's all it will do now. The LED's blinking about once a second. It's still being told to go and fetch the code from the real-time clock, but no code's coming back, and it will just sit doing that indefinitely. Now, I've probably just lost a couple of seconds on this because I put it bottom side down. The crystal on these and the amplifier circuit is really weak because it's designed to this little button cell to last, they reckon, up to a year with no power. It will run it. So as a consequence of that, any sort of external interference like capacitance or anything across the chip pins just stop it from working. So I've probably just now messed up the time. But what I can do, when I plug this back in, let's go more to the edge of the board here. If all goes well, there we are, and the time is off again. So if we wait, it doesn't fetch the minutes until once a minute, so it might go straight from 31 to 33 if I had it out long enough. There you go. So yeah, because it requires more code to execute to get the hours and minutes, it's only about once a second it's sent off to fetch the seconds. So yeah, anyway, that was just the point of this video. I just thought it was quite comical that I've decided to make a clock that literally cannot be set. The LED, I like putting little LEDs. It's just like the very start of the program. It just basically exclusive ORs the value of port, whatever port register that's connected to, against 1. So if the port in that file location was a 1, it becomes a 0. If it's 0, it becomes a 1. And it then tells me, even if, say for instance, and it happened with this, my display wasn't displaying anything, but the LED is still flashing, it tells me it's not stuck in a program loop or got lost from too many calls in the stack or something, because it's only got 2-level stack on it, this chip. I had to rewrite a lot of the code because obviously you write a function and it itself shares other functions, so you call functions within functions within functions, but you call a function on this, or you can only call one more, and then you run out of stack spaces, so you have to do a lot of manual code. There's no interrupts, so the whole timing routine bases around just sitting in a loop waiting for the timer 0 register to equal 128 more than what it was last time. And round it goes. The chip itself is actually connected to a very high precision 32,768 hertz crystal, which is watch crystal. If you do the maths, you divide that by 4, which is what the internal latch does for the processor, then divide it by 256 to go into the timer 0 register. Well, every 32 increments of timer 0, I believe that setting, or 60, whichever it works out to, is exactly a second. So I did actually, before interfacing the DS1302 RTC module and just interfacing with the LED, I actually had a clock running just using the crystal on this, and after a day it was bang on to the second itself still. But the whole point was I just wanted to interface it with the module. But there is a lot going on here, because the display drivers for the LCD, what are they? They're like a Hitachi, I could be wrong here, I'm just going from memory, it's something like an HD77480. So it's interfacing with an external, basically miniature computer, PIC, whatever a chip, whatever protocol it uses for the drivers for the display, and it's interfacing with the DS1302. And considering it's a baseline flash with 25 bytes of user RAM and only 512 lines of programming memory, it's got no interrupts or anything, there's no port interrupts, there's nothing. Everything has to be done by looking at ports manually, then trying to make it execute code rather than just saying sit here, do nothing, wait for something to happen somewhere else, then act on it. yeah, it was just an exercise in programming, and it's up and running, and that's what I'm just going to leave it doing whilst I work on other stuff. But so anyway, just thought I'd make a random video because I haven't made one for a while. And as always, thanks for watching. I'm quite involved with this project now, so it will be coming up on this channel soon in various bits and bobs. I should have a bit more time on my hands now because they're knocking a shift off at work. We're going down from working a rotating free shift pattern of earlies, nights, lates to just earlies and lates. So no nights will mean less night shift fatigue, a little bit more energy and a little bit more time to do things like this, although slightly less when I lose about 8% of my wages. But hey ho, is what it is. But anyway, as always, if you took the time to watch this video, thank you very much, and hopefully catch you next time.